Okay, for this next problem then, same idea. We're going to identify how many isotopes we have, and the problem says that we have 3. That we have uranium. Oops, I'm not on the screen there. Uranium. Let me start over. Uranium, and it's 234. I have uranium 235, and then I have uranium 238. And then I have my percentages. So the percent abundance for uranium 234 is 0.01%. And for uranium 235, it's 0.71%. And then for uranium 238, it is 99.28%. So the first step, remember, is to change my decimals to a percentage. Or sorry, I said that backwards. To change my percentage to a decimal. And so to do that here, I'm going to move twice, 1, 2, which means I'm going to have 0.0001. So it's really small. Same thing here, 1, 2, so 0.0071. And then down here, same thing, 1, 2, so 0.9928. So now I have my percent abundances that changed into a decimal. I know my masses here because it was given to me in the problem. So I'm going to take my mass times my percent abundance that's been changed into a decimal. And I'm going to keep doing that for each one, making sure that I'm adding those terms together. So then it'd be 235 times 0.0071. And then it would be the last one, so 238 times 0.9928. Now, a couple of things here. This is what your work should look like what I showed you in the first problem and now in the second problem, that you should have your isotopes listed out because these are your variables. And that's one of our steps for our criteria for success for problem solving, is that we have our variables listed out, right? This is the other part then, that this is my equation and this is my work here that's shown. And there's not a whole lot of manipulating because you're always solving for this, and so you don't have to move things around. So then on your calculator, you're going to do this too. Now, be careful to put the parentheses in, right? Because you want to make sure that it's not just doing the addition and then adding to the next number, but that you're actually doing that addition before. So if you got the wrong answer on the previous question, it might be because you're not including the units, or the parentheses, I'm sorry, in your problem. So I'm going to show you what that looks like in one sec. So you should literally have the units right in there for that. Okay. So now I'm going to hit enter. And the answer that I get is this 237.978. And the units are AMUs. And I only want 2 after the decimal, so 237.98 AMUs is going to be my answer then there. Now, there is a trick to always check your work, and the trick is this. Whatever isotope has the largest percent abundance is what your answer should be closest to. So because most of this isotope occurs in the form of 238, our mass, our average atomic mass, should be closest to 238, which it is, 237.9. It should be a little bit below because we have some other ones that are a little bit below that, but our mass should be closest to the largest percentage that we had. You can do the same thing with the one that we just did, the rubidium, right? And that 72.2% was the largest one, and it's rubidium 85. So my answer should be closest to rubidium 85, which it is, right? So it's just a quick way to check your work in case you feel like you might have done something incorrect.